this time. So I'm going to run my talk, and then it's sorry, I don't know your name, sir. And then search on talk on
Linux beta.
On beta. So just in case anyone's confused about the timetable. Reproducible Builds. Film the original on this piece. Everyone can see this, okay? Brilliant. So let's start with a little bit of that. Hello. I believe that's been covered already, quite nicely. Let's start with a little bit of a history lesson. I guess everyone knows who this chap is. So I'm not sure exactly when he wrote them, but these 4 freedoms seem to come out of like the 1970s, 1980s kind of idea about free software. So freedom to study how the program works, freedom to run the program, freedom to redistribute copies, freedom to make derivative works and distribute them. So these are all things people know about free software, etc. He labels them freedoms, 0, 1, 2, 3, 4. This is just classic free software stuff. So, but today we're just going to be talking about a few of them. So we don't really care about right now just redistributing copies. I mean, sort of we are, but not really. And modified versions. This is something very different. We're primarily concerned about these first two. In particular, how to run the program. So this is quite an interesting concept in the sense of, like, what program are we running? Because whilst we can always look at the source code of free software. Hi. Whilst we can always study the source code for malicious flaws, when we actually download software, we are basically, like, unless we're running Gen 2 or something like that, we're pretty much just using someone else's compiled binaries. I mean, what we're doing, okay, you can't see that very well, but I think that's someone installing Apache, and that's the apt-get. So all of this stuff is just being downloaded from some server that's been built by someone, and you kind of trust this, but you...
Although it's signed though.
Signed? Sure, but I mean, okay, I'll sign something for you now. Install it on your machine. Are you going to say no, right? Because all of this stuff like runs as root, etc. So yeah. So basically, whilst you do have the hi. Yeah. So what we have one part of it in the sense of you can look at the source code. But what's actually running on your machine? These are like kind of important concepts that we kind of are confusing. So this compilation, can we like trust the whole process of getting software from our vendors, from our distributions and things like that? I'm not sure we really can. There's been lots of, is there an issue here? Or? Are you good? There's been issues where like rootkits have been installed on developers' machines, and then the software they produce, therefore it includes rootkits. And they most famously a company made a fake download page for, I believe it was the iOS SDK. Then people downloaded it, made applications for iOS, uploaded them to the App Store, signed by their keys. I completely trusted software on their machine. It looked fine, and then I believe it just had adverts that weren't theirs, and that's how they realized what was going on. So, but hello.
I think there's a typing error, so you have until 2 o'clock. Is that okay?
Well, should we just continue for now, and then?
Yeah, you have until 2 o'clock. You're not sharing the session here.
That's fine. Yep. I don't understand.
We have 102. So
So let's just continue and see what happens.
Yeah.
All right. I don't, unless there's a big problem. No. Okay. Cool. So the adverts appeared and it's all signed, and so it's like, well, brilliant. And that's just someone trying to just make some money from ads, right? You can also read like things about I think it's some slides on the CIA about how they could plan to do this into compilers and things like that. And this is all available on the web and through our website if you want to check that out. So the other thing is like currently the whole model puts individual developers in a very kind of difficult position in the terms of someone can come around my house, like men in black coats, can come around to my house and say, so we have this secret about you. We know what your favorite things to do in your spare time are, unless you or your favorite drink or whatever. So they could basically say, unless you introduce these backdoors into this important piece of software that you write, like maybe it's Tor, maybe it's absolutely nothing, we will reveal the secret about you or send some heavies around your house. Basically, they can kind of threaten you or things like that. This is really bad because it means that individuals are so much more easy to be targeted than a whole group.
Excuse me.
Hi.
Let's just go outside. If you guys want to talk, please, because we're trying to listen.
Outside.
Thank you. This sets up individual developers to be targets, which kind of sucks because they often are just like 20-something-year-old university students, and they have quite a lot of control. Like they have commit rights, so they could add source code vulnerabilities, but they could also just add some rootkit to some build server, like things like that. So all the binaries that get produced from there are compromised. So we kind of don't want that. We kind of want to kind of spread this kind of risk out, so no single individual can be targeted and things like that. We've no like idea that this is actually happening, but like the number of like core developers in say like Tor, Bitcoin, etc. are quite small, and so you wouldn't need actually that much resources to kind of go after that kind of route. So that kind of thing. So our solution is reproducible builds. So the way it works is we basically ensure that compilation of any piece of software always produces the same result. And by that I mean bit for bit identical. You run a SHA-1, MD5, whatever, you literally get the same binary every time. And then you basically, everyone or no one or as many people as you want do the same idea, run the same build. And if you get the same result, it means that everyone is basically using the same tool chain, the same source code, the same hopefully non-rootkitted or Trojaned compiler and things like that. And this basically means that if an attacker wants to get into this trusted network or introduce flaws, they need to basically infect everyone at the same time. So I need to infect your laptop, I need to infect Kai's laptop, I need to infect mine at the same time. Otherwise, at a certain point, your binary that you produce will kind of have one particular checksum and mine will have the other, and we'll say, oh, hang on, why are they different and things like that. So this sounds like you could kind of do it already. Unfortunately, when you build stuff right now, and the idea is that then you can trust what's happening in the system. So the problem with this right now is that if you actually build a piece of software in 2016 and then you build it again even on your same machine, you just press up enter, you get a different result. Like this is absolutely kind of, I didn't actually believe this when I started, in the sense of no, this will just be some weird things you can easily fix. But no, this is actually a really deep problem. So I think the sort of 80% case is like everything embeds timestamps. Like people just love to add timestamps to builds. Like they add underscore date and underscore time in C++ headers. Add it to documentation. This was built on blah. You want to do -- help. It puts the time it was added in. Those are difficult to kind of get rid of. You also have like things like time zones or locales. So if you build a piece of software in a certain locale or in a different time zone, you will get a different result and a different binary. which is often really the case. Different versions of libraries. I mean, of course, if you have different dependencies, you're going to end up with different results if it's statically linked. Non-deterministic file ordering. So if your build process slurps through a bunch of just looks in a directory for a bunch of images and adds them to a certain like sprite or something like that. Redo the Unix syscall for returning the results of a directory doesn't actually specify that they come in alphabetical ASCII vertical order. So your binary can end up with different results because this order is completely non-deterministic. Also things like if you are doing even linking using the GNU linker, if you just use a wildcard like in shell, etc., star, that's not necessarily guaranteed. That's in reader order, not in ASCII alphabetical order. And so you can just have different link ordering, different sharp, whatever. And also like things like to various build processes will include just various stuff from the build environment, just suck things in. So I mean, a classic one I didn't put here is it will set the number of default threads to the number of CPUs, which makes sense, but it's the number of CPUs on the build host, so it's not actually that useful when you go to actually run it, because often your build host has like 64 CPUs anyway because it's a build host, things like that. Also, there's like just misc random behavior, so it will loop over the keys of a dictionary, which are generally non-deterministic, particularly in Perl. It's particularly random in Perl in the sense of when you do percent keys, you will just kind of get an arbitrary order because that's just how a dictionary is implemented in these languages. Build paths are other things. So if you compile a binary and then look inside it using sort of a hex editor, you will find artifacts where you've actually built that piece of software in your file system, like it might say home, foo user, git, my projects, blah, 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 things like that. So these are all things that make builds differ on their SHA, etc., or whatever hash you're using, etc. I didn't actually fill that in, but we can go back to this page. So timestamps, we try and remove them as much as possible because they're kind of slightly meaningless. Like when you built a piece of software is like not actually part of the piece of software. It's not really part of the binary. I mean, sure, include it, but who really cares? Time zone locales, hopefully you can just get rid of the behavior that changes. One curious thing with locales and time zones is certain date time libraries, sometimes like the tests will fail if you run it in different locales and things like that, which is very interesting. Different versions of libraries, we have a solution where we've introduced a concept called .build info file, which captures the entire build environment used to make that piece of software. So it will say, okay, we've built, I make it up, Vim version 1.4, whatever. And but to build this version, we have used GCC blah. We have used the standard library version X. We have used all of these different libraries that are all the build dependencies and things like that. Non-deterministic file ordering, we basically just sort the files and change the behavior of the build system to make it deterministic. So instead of using a wildcard and things like that, we will use a wildcard, but we'll also additionally sort as well. Uses masks, so this usually is a sign of something kind of a little bit broken in the binary, so we'll just try and fix that explicitly. Random behavior, you just have to fix. So for example, if you're iterating over the Perl keys, you will just add, for example, a sort to make it deterministic, things like that. Build paths are actually complicated because of the ELF file format. The interim solution we've currently landed on is to basically have a fixed build path and specify that in the .build info file that I've mentioned, the different versions of libraries. So I think we just by fiat say everything's going to be built in /temp build and then the name of the piece of software. and so that the ELF binaries still encode the build paths, but at least they're fixed. So, and there's at least a policy on it. So if you want to have a reproducible build, you will use that .build info file that says, oh yes, please use these build dependencies and build in this particular path, and then you'll get the same bit-for-bit identical binary at the end. So these are some of the challenges. Hi.
Yeah, so also, if you were to use the compare the ELF object text section, then I guess that would help with some of those, because obviously strings are in a different section, our data section.
Correct, but how would you normalize them to be the same? This is the problem.
But of course, you wouldn't care about the like strings in the other sections, but just like the text section, you'd address a number of those issues if you were like looking at the chart of the ELF text section of your binary.
Right, but you could certainly do that, but that means that your specification, your definition of reproducible is now oh, it's reproducible, but as long as you ignore ELF text sections, and then
the opposite. Yeah, you only want the text section.
You only look at that.
Yeah, that's the whole idea, right? If you're interested in the code.
Oh, yes, but there's more to life than ELF text sections, right? There's more code. I mean, there's assembler, there's blah, there's non-ELF binaries, there's Python. So you basically want to use the lowest common denominator and just say you're the entire package. So your RPM is literally bit for bit identical. Your .dev is bit for bit identical. So having like specific things that only or ignore parts of a file become extremely suboptimal very quickly. You have all these exceptions, things like that. But you're right. I mean, and hopefully we will be able to rewrite ELF binaries, for example, after building, so you wouldn't have to do that. It's kind of complicated because, well, ELF is just a complicated file format, but something like that. So let's go with that. So, unless you can also not care, you can have like a tinfoil hat attitude to reproducible builds and like, oh, no one can attack your system, etc. But there's a number of technical advantages as well, such as one particular that's very useful for companies is they'd be able to go back in time, and by that I mean they've built a piece of software and then they put it into a car, and but then 5 years later they actually want to see what they actually put into the car. They've lost all their build. They want to just make a new version with this small change or something like that. But if they built it now, they have no real idea that what they've built now has any real bearing on what they built in the past, because like all the binary is just different. So yeah, and so being able to go back in time would mean, by that I mean they could actually just, oh, I built this 5 years ago, I built it now, it's the same, right, now I can make my changes and be confident that the changes I then introduce only factor in what I want to change, just any change. It also detects corrupted build environments. I don't mean tainted as in like corrupted in terms of tainted or evil, just where you've meant to have like a clean build environment but you've accidentally installed some rubbish to it, or it's just got completely screwed, and so once your binaries that it produces start becoming different, you've realized that you've messed up your lovely pristine clean environment in some way, so you have to easier to test change and revisions. So by that I mean you build a piece of software and then you're like, okay, I want to make this extremely minimal change. You change it, and currently if you then compare the two, for example RPMs or devs or whatever, you'd see a whole bunch of unrelated changes that include all these timestamps. It wouldn't just focus on what you changed, you just change like a underscore to a hyphen. You'd have all this other nonsense thrown in and things like that. And so if you've removed all of that non-deterministic random behavior, your diff then only refers to the things that you've made changes to. So therefore you can just easier to test them, and you can just have a bit more confidence about your software development process. So there's even more technical advantages in this. So it's just really good sort of software engineering kind of practices that we've managed to completely neglect for years and years. So within Debian, I think we have the most progress in terms of distribution, things like that. We're continually testing the entire archive. Hello, is there a question?
No.
Oh, cool. We're continuing testing the archive. We can now build it extremely fast. We've got some sponsored machines. I think that gigabyte RAM is low now. We build on AMD 64 and ARM HF, which is an ARM variant, and 20,000. So that's sort of 85% of our packages are reproducible. So you can take a package, build it again, and you get literally the same file, which is like kind of cool. We still need to make some core changes to some things like depackage, and some core changes to some of the archive tools, such as the Debian archive kit, which basically is what makes like an apt repo and things like that. And that, for example, the build info things that specify the dependencies and the build path, etc. So we still have some changes to make, but hopefully the next distribution of Debian should be reproducible, hopefully more than 85%. We try and split up internally what these 20,000 packages are, so we focus our efforts on the most important things. So all the games, for example, we like deprioritize because it's sort of a game, it's very important, but we'll prioritize like what we call the essential package set, or the build essential package set, etc.
It would seem like the most important packages for you to get reproducible are all the build toolkit stuff.
That's right, yeah.
Compilers, the linkers, the optimizers, basically anything which produces anything else in the whole package. Because without those, you're totally hosed. If you can't depend on your compilers being reproducible or your tools.
Absolutely, yes, and you're quite right. So like games would be leaf nodes in this thing. So yeah.
So is there some theme to those 3,500 packages which are not reproducible, or is it all like some individual wiggling that needs?
So some of them are. There's some themes. What we do have a system of categorizing issues. A lot of them. And so we'll say, oh, this package isn't reproducible because of issue X, and then we'll encapsulate all that we know about issue X into one place, and so someone can just be like, oh, I'm going to try and work on this, and then fixing that would fix, hopefully, 200 packages at once. You're right, some of them are just like completely arbitrary, like that particular package has this thing where it just shoves a date in X in here, like someone just needs to go in and fix that particular one. Luckily, a lot of the remaining ones are just things like documentation. So, for example, Bash, quite an important tool. Doesn't necessarily produce anything in your sense, but let's get Bash reproducible, right? Because people use it a lot. It's only non-reproducible right now because of something in the documentation. It adds timestamps everywhere, and yes, we could fix it individually in Bash. But we'd like to, I don't know what it uses, probably ASCII-doc or something, some GNU tool or something. We want to fix that generally. So, yeah, so fixing those patterns are the important thing.
Can you get GCC not to put in the timestamp?
Excuse me?
Can you get GCC not to put in the timestamp?
GCC is an interesting case. So we have some pending patches on the GCC mailing list that let you specify at build time using an environment variable what will be produced when you use __ date and __ time. Those preprocessing macros. It's too much of a stretch to remove those preprocessing macros from every piece of software ever. In an ideal world, we would never have added those really, but whatever. So we have a cross-distribution specification for injecting those timestamps into essentially legacy things like that. And so we're still waiting on that. Yes, a lot of those 3,000 left over are these preprocessing macros. So,
would it be easier just to strip off the timestamps as part of the package process?
We do have a tool that does some stripping. So we call it strict non-determinism, and for some file formats that works really well. So a classic example would be the PNG format, the image format. The timestamps are in a quite predictable place, and you can just remove them or set them to Unix 0. Usually they're completely meaningless. Like ping, great, you made it on this date, big whoop, like no one cares. So we do have that tool, but for things like _time, it's not really possible because they can be in the binary. They can end up in almost any arbitrary format because they use like stripprint F or those kind of things. Like somewhere differently.
Okay, so
hello.
We're done, right? So you want to wrap up?
Yes, I'll happily wrap up. Yeah, 2 minutes. Thank you. In the process of making all these things reproducible, we've made a whole bunch of tools. One's called Diffoscope, and this is the web-based version of it. So what you can do is upload 2 files, and it will give you a diff between them. Sounds like a normal diff, but no, Diffoscope is different. It'll actually recursively unpack as many file formats as it knows. So you can give it 2 ISO images, and it will look inside the ISO images, and then inside those ISO images you've got some tarballs, and it'll unpack the tarball. And inside that tarball there's a gzip file, and inside that gzip file is something else, and it'll just basically go all the way down and give you an extremely nice diff between the 2 things. It accepts RPM, it accepts deb files, it accepts I think it even accepts ButterFS images. I think so. Yeah, X2. Yeah, it's a great tool. So this is that try.diffoscope.org. You can just basically upload files and it'll compare them for you. Beyond Debian, we're not the only distribution caring about this. Coreboot, OpenWRT, these sort of slightly smaller distributions. Just going to skip over some of the others. We had a cross-distribution summit meeting in Athens in December. That was really, really good. Made a lot of progress. I'll skip over independent rebuilders because I'm running out of time. Getting involved. So test for yourself. So if you have a piece of software, build it once, build it again, notice how the SHA changes and like cry because that just shouldn't happen in 2016. If your program does use dates explicitly, either stop using them or use source date epoch, which we have a spec here. You can also find it on our site. Visit our website. Notice it's not Debian specific because this is a try and be as Debian unspecific as possible. And stop by Reproducible Builds on OFTC, IRC, and that's where you can hang out and things like that. So yeah, any questions, comments, queries, etc.
You should hook up your website also to VirusTotal. Send a copy to VirusTotal.
Oh, interesting. Yeah. Okay.
So, how do I check the like say I'm running Debian, how do I check my binary is still good? Is dpackage secure or something?
So we currently have no client, essentially what we call client or end user tools for checking whether a package is reproducible. This is because we have no canonical idea of what it should be, because we don't have an official SHA for a make it up bash. The bash you got installed in your system was compiled by some builder in some cloud somewhere, but we haven't actually said that that's the official one. So therefore, no end user tool can say you are running that version there. So this is part of the core changes to Debian that I was referring to earlier.
So actually, DebSims will tell you, but of course it'll obviously give you a false positive if it will give you in fact a false sense of security. Of course, if the actual build itself is modified.
Yeah, DebSums will say yes, your version is completely fine in terms of it matches completely the tainted thing that So yeah, exactly. Yeah.
Okay, let's stop here. Round of applause.